Hi, happy return. So I guess this is one of the easier topics in grade 11, which is just adding and subtracting polynomials. You have run into this at some point, so probably not with functions when you're studying those, but you have taken basically polynomials just as simply expressions. And that was in grade 9, and I'm sure you did a little bit in grade 10 because you did a lot of quadratics, which are part of polynomials. So I'll put up a link up above there to the kind of grade 9 material to kind of adding and subtracting. And here I'll dive a little bit deeper, but it should all kind of be familiar if you've done polynomials in the past. So from the viewpoint of functions, I still like to always kind of have this input and output. Okay, so we have our independent variable coming in, we have some kind of a function, typically sometimes we started off with just relations, and then we have an output. Now, if you're only going to be talking about polynomials, we have quite a few of them. Okay, so if our f of x, okay, is basically just a constant, so for instance, let's call it some a, and maybe I'll put a little 0 here as a subscript because I'm going to be using a quite a bit. Now, assume a0 is just some number. So, an example of this, let's say f of x and then my output, we have done. So, for instance, if you had something like this, which your output basically is constrained just to be a constant, so some real number. And you know that if you were going to be graphing this, then it's just basically just a flat line. So this would have been an example. Now, if you carry this on and you kind of make this kind of more and more complicated, so let's say f of x now, instead of just being a constant, let's say that it was, for example, a1 multiplied by your input x plus, that constant a0. Now, when you're looking at this the way that it is, you might think, what is this? But you have studied this to quite an exhaustion. So these are basically just lines. And, so don't forget, our lines are y is equal to mx plus b. And so basically your m, that's your a1 right here. And then your b, okay, that is your slope, your y-intercept. So this particular form, so this was just a monomial, right? Because it just had one term. So here we have two terms. The order of this polynomial is 1. The order is what the exponent is on the x on the input. So the exponent, we don't really put a 1, so x to the 1, we just write x. And these are basically just lines. So again, you have run into this even before grade 9. You have also run into lines most likely before grade 9, and you've studied them quite a lot in grade 9 and also in grade 10. And you can go back to my videos from grade 9 and 10 if you like. Now, you can keep making this a little bit more complicated and make these polynomials bigger and bigger. Now, polynomials will only have for this particular video, and since we're kind of dealing with functions now, are going to only have one particular input. So you're not going to have multiple inputs, at least not yet. All right, so not necessarily in grade 11. So the next step up here would have been kind of like this, so you could square your x, and then you can do something like this. And this should be very familiar to you. This is just nothing else but a quadratic. So notice the order is 2 because we're squaring it. Now it's no longer monomial or binomial. So binomial had 2 terms. This one has now 3 terms. And, so this is kind of the beginning of polynomials where you have multiple terms and you can just keep going and going with this. So the next one up, could have been maybe, let's say, a to the 3 x cubed, and then it goes a subscript 2 x squared plus a1 x plus a0. Now, all of these, these a's, so these are just numbers. So for example, so what you would have is, if I wanted to write this out, we generalize these to some a's, but they could be, for instance, 4x squared. Let's say this could have been minus sorry, 4x cubed, because we're doing the cube there. Let me go back in here. Let me just fix this a little bit, okay, so that we have that as cubed. And now if I, continue on here, let's say plus 2x and let's say minus 1. So in here, so these are actually your a's. So a3 in here is just 4. a2 really is just -1, which is in front of there. And so that's a2. a1 is 2 right here. And then a0, I guess, is -1. So you take the sign with that. So those are not necessarily new. And of course, I can make, the orders even higher and higher. So I can make x to the 4, x to the 5, and so on and so on. The first three we are definitely very familiar with. So in terms of just constants, here are lines and here are quadratics, right? So those ones we deal with quite a lot. The ones that you follow, those ones maybe we're not as comfortable with yet, but polynomials are actually the easiest functions to deal with. And now, because we have numerous tools to graph, we can also graph them as well. So I'm not going to necessarily do any graphing here for us at the moment, but I do want to finish this off and generalize this. So polynomials that you're going to be dealing with, could be basically to any order. So to some order n, so plus, this would have been to the order n minus 1. So this is x minus 1. So notice that they're basically just kind of decreasing, okay, as they're going through until we eventually, get to, so here is a1, x, and then plus a0, so plus your constant. So that's how a polynomial looks like. Now, these particular polynomials, so if you're thinking of the domain and ranges, so the nice thing is that, the domain you don't really have to worry about because we don't have any denominators. So every value of x is fair game. And because of that, it makes our life a lot easier. That's why polynomials are a little bit easier to deal with. Now, in terms of the range, so you saw even a quadratic, because they're parabolas, the range isn't everything, right, that you carry through. And if you forgot about domain and ranges, I'll put up a link up above there, I guess, for you in case you want to refresh yourself. So you should keep that in the back of your mind as you're going through. So now with these polynomials that you have, let's do a few examples. And these examples shouldn't be too bad for you. So here is one example. So I'm giving you two kind of functions, so f of x and then g of x or g at x. Okay, so here they are. So these are the two that they give us. And now because we're dealing with adding and subtracting these, so you should be able to, for instance, collect your like terms, and you should understand like terms. And that was something you did in grade 9. And, so for like terms, I guess I'll put up a link up above there for you. So let's try to do this as an example and as basically a refresher. So it says we have, so f of x, so x squared plus 6 minus, all right. Now I like to put the g of x in brackets. And then so g of x is 4 minus 7x plus x squared. So how are we going to subtract these? Well, the negative, so this negative will be brought in, okay, inside of here. And what you're going to have is your f of x. So now it's going to be minus 4 plus 7x. So we're just distributing. So all of this should be familiar to you. It's a nice kind of addition and subtraction of polynomials is a pretty nice thing when you get to grade 11 because you've done it in the past. So now I'm going to just collect like terms, so for instance, we like to start with the highest orders. Okay, so x squared, I guess there's an x squared here. So 3 minus the 1, so this is going to be 2x squared. So those ones are gone. Then, do we have any x's? Oh, we do have an x. Okay, so we have an x right here. There's no other. So I'm just going to leave it. So it's going to be plus 7x. So that one is gone. And then 6 minus 4 is just plus 2. So that would have been your new expression that you would obtain from subtracting g of x from f of x. And this would have been maybe a new function. Notice that it's basically just a quadratic. So we can utilize the tools of quadratics and graph it if we ever wanted to. So you should be comfortable in adding and subtracting. So here's another one. So I'm just going to switch the variables around so we're not just dealing with x. The input is not always x. So for instance, notice the input here is t. So maybe t means time. And, so I switched it so it's not f, it's v1 and v2, whatever that might mean. Now, in this question, we're going to be adding these two. So if you're going to be adding them up, so again, so you can write this out. So 4t squared minus 3t plus 5. Now, addition is much nicer. So, you can still put it inside the bracket. I'll leave that up to you if you want to be able to do that. So we have this. And of course, the addition is not going to change any of the signs. So we can technically get rid of this bracket right here. And then that addition, so it's going to be just, it won't change anything for us. So now let's take a look. Again, let's go from the highest order. I'm just looking. So I guess t to the 4 is the highest one. So this is going to be t to the 4. So that one is gone. There is nothing else. T to the 3. All right, so that's the next one. There are no like terms with that. So this one is gone. And then we have, so this is plus 4t squared. So that's this one right there. And then minus 3t. So, and then 5 minus 10. So I guess it's going to be minus 5. So there wasn't really much additions in here because we didn't have many like terms. And again, so this would have been your new polynomial expression that you would have. So this is to the order 4. Okay, so notice this is 4. How many terms do we have? We have 1, 2, 3, 4, 5 terms. So it certainly is a polynomial. Polynomial is basically anything kind of more than one term that you would have. Here's a final one just for, I guess, for kicks for you. So if you have these two, okay, so let's imagine that these would have been our functions. So my input is a. So this is not the same a as before because a, I said, was a constant before. Now it's an actual input. Okay, so it's kind of like x. And then what we want to be able to do is we want to be able to subtract these. Now notice they said t, so we're going to go t minus h. So let's write down. So 4a to the 4 plus 5a squared minus 3a plus 4. Now it's subtraction, so I'll put it in brackets in here. So 14a to the 5 minus 3a squared plus 7a plus 1. All right. Now, so you can bring in the negative inside of the bracket. Okay, so I can bring this inside, so the signs will all change. I have to do that to all of them. All right, so you can do that. That's going to be this. This one will become positive. This one will become negative, and this one will become negative. And now you can go ahead. So I guess the highest order is 5. And so for this one, that's the only one I have. So minus 14a to the 5. Anything else? No, so there was no other 5s. A to the 4, I guess there's only this one. So plus 4a to the 4. And then it's squared. So squared, I have 2 of these. So 5 plus 3 is 8a squared. And then it's these ones, so negative and negative. So it's going to be minus 10a. And then 4 minus 1 is going to be 3. All right, so this is to the order of 5. Okay, so this polynomial, so that's the highest order. And it has 1, 2, 3, 4, 5 terms. All right, so it is a polynomial. So these additions and subtractions, when you run into them, are indeed one of the easier things that you will do in kind of grade 11 functions in your course. So I hope that this was useful and kind of a refresher from kind of grade 9s and 10s in terms of adding and subtracting polynomials. All right, we'll see you in a future video. Okay, bye everybody.